tutorial explains how to correct shifts in retention time when, for example, cutting a piece of a column. To demonstrate this, we use the demo data in GCMS solution sample, and we open up aart 30 m. This is a pesticide standard measured with a 30 m column. So we see the compounds are identified, but the retention index is 0. To set the retention index automatically for all the compounds, we have to measure an alkane standard with the same method. This has been done already, so we open up the alkane standard for the 30 m column, and this alkane standard has the following alkanes, and we see the name must be C and then the carbon number, and then the retention index should be set correspondingly multiplied by 100. Important for this is, after acquiring the alkane standard, we have to perform quantitative integration so that the result table has the corresponding entries. If that is done, we can update the retention index in the aart 30 m data file. So we see the retention index is 0. For setting the retention index, we click Wizard Modify. This wizard allows several items. One of them is to modify the retention index. In this case, we modify the index from 0 to the right value. And we click Retention Index Parameters, and in this index parameter window we select the alkane file for the 30 m. So the alkane file for the 30 m define now the retention index with the corresponding retention times. We press OK, we press Next. All the other sets in the wizard we can take out because we only want to calculate the retention index for the several compounds. We press Next and Finish, and this makes the retention index database out of this method. So we save that file, and now assume that the column is cutted by 10 or 20 centimeters. All retention time are shifted. This is by seeing the aart data file for 24 meters. We have shifts in retention times which can be seen in data comparison. So we have the aart 30 m and aart 24 m data file, and the peak are considerably shifted in retention time. So what we do have to do is we have to acquire an alkane standard again on the 24 m column. And remember, this compound table comes from the 30 m. Retention times are not correct. So next step is to measure a 24 meters alkane standard with identification of the corresponding retention time, retention index, and integration result. This is now based on the 24 m, and the next step is now to update the compound retention time of the pesticides, of the targets. To do so, after loading this alkane file, we select Adjust Retention Time using the aart function. So now the 30 m method is the one we want to update. So we can save that, and now we have the corresponding new retention times in here based on that alkane standard. So as we can see, C13 has a retention time of 6.312 minutes, which is indicated here. So pressing the next button, we see that the retention times are updated based on this alkane injection on a shorted and cutted column. We see the retention time is considerably shorter, and when we finish, we have updated our originally 30-meter column method. So now we want to quantify and find our target pesticides back again. So we open up the 24-meter pesticide data file, and we load now the modified 30-meter column method in, which is this one. We load that in, press OK. Now the retention times are modified and they are smaller, and if we now do a quantitative integration, we should be able to see all the pesticides, which works. So this is the way how to update a method retention time by using the aart function. The aart function also updates MS parameters like indicated in the window where we modify the retention time.